It is unprecedented times we are living, and also around us, so much uncertainty is happening. So thank you again for taking the time to share and discuss this topic with me. It also shows me that how relevant this topic is in today's market. It is about technology, it's about hybrid cloud, but at the same time, so it is relevant in all sense in whichever field you are in. This topic is very topical, and I'm very happy to discuss this with you. I wouldn't call it as a presentation. It's more of a, I would like to this to be a more of a presentation. As madam mentioned, I've been with IBM Australia for the last 14 years, different roles within IBM, and last few years I've been in the services organization of IBM. I'm very fascinated with technology, and throughout my career, I have been doing something or other around technology, both in technical and also from a sales perspective. So, in the last about 10 years, I've been working with our customers in Australia, helping them with the journey to cloud, and also from an infrastructure perspective to sort of shape where they want to go in the next 5 to 10 years. That is why one of the reasons I chose the topic to be innovation at speed. It is not just about hybrid cloud. I'm not going to present very detailed technical topic of hybrid cloud because I know I have a variety of audience here. Hopefully this will resonate well. If any one of you want any more detail on particular topic I am going to discuss, please let me know. I'll be happy to talk to you about it straight after the session. And also from a questions perspective, I think we do have quite a number of people on the platform here. So if you can park the questions for the Q&A session, I promise you I will have some time for that. Let's discuss the questions you have. This is a topic which I'm very passionate about, so more than happy to touch on any questions you raise. We will discuss that as well. Moving on, the topics I would like to cover today is why did I choose the word speed, innovation at speed, for discussing hybrid cloud. I would like to touch on that. And from a COVID perspective, what is happening around us from a technology standpoint? What are we seeing from a corporate perspective? What are we seeing in the market with our customers? And what am I talking to customers about in a daily fashion? I would like to touch on an evolution of technology, where we are today, but again, technology revolution as well, because that is what we are going through today. Past is good, we need to have a view of the rear view mirror, but at the same time we need to look at the future as well. So that is something I would like to discuss with you about. And then touch on digital transformation. I understand one of my friends who presented in the last couple of days touched on digital transformation. So I will be, hopefully it is not a repeat. So let's see how it goes. I would like to share my thoughts, what digital transformation is about and where I see market going, again, from a customer's point of view. I'd like to talk something about competition versus co-opetition. That is a newly formed term that I would like to very quickly touch on. Then we will talk about hybrid cloud in the context of infrastructure, in the context of what is happening in the IT space today. And then we'll wrap it up with few information I would like to talk to you about. So, without further ado, let's move on. First thing, as I said, from a real need for speed perspective, I'm not sure how many of you have seen this video. This is a TED talk by Bill Gates back in March 2015. If you haven't, please Google it. It is on YouTube. You should watch it. The reason I'm starting with this slide is, look at the time. March 2015 is when Bill Gates did this speech. It's an 8 minutes video, and at that time he forecasted by saying we are not ready for the next epidemic. The context to that line he mentioned was Ebola. We had Ebola back in 1967, and it was a big outbreak we had in 2014 to 2016 period in Africa. It was the massive outbreak we had at that time, those 2 years. And that is a cusp of the time when Bill Gates is providing this presentation at a TED Talk, March 2015. And he was mentioning that we are not ready for the next epidemic. On top of that, what he mentioned in that speech was the next big one to stir up the whole world is not going to be anything like a nuclear war. He specifically mentions that it is nothing to do with nuclear because we are very ready for that. Countries are sort of they're expecting something to happen around nuclear, so they're all getting ready for it. What will happen, what will be the next big one is going to be a very tiny microcosm. It's a microscopic item that will come into the world that will disrupt the whole ecosystem we have today. That is in 2015. What he also suggested to the governments at that time was to be ready. He gave 5 points. With the first one was to have the health system, stronger health system in poor nations, to keep the medical reserve corps ready, pay medical and military operations. So what he means by that is he wanted governments to link the medical system and the military operations, because when something like that happens, he expected these teams to work together because it will be in a massive scale. He wanted companies, research institutes to run germ games. Again, the intent of that is going to be around, again, as suspected, we wanted more quick turnaround in results when such a thing happens. And the last one, stepping up of R&D across all space, or it could be corporate, it could be education institutions. He said more money needs to go into the R&D space before something like that happens. Fast forward 5 years. Today we are less than 5 years if you strictly look at it. This whole thing started, Corona started back in December in China. It is less than 5 years. The situation we are facing today is exactly as he predicted 5 years ago. We are having cases all over the place. Countries have shut down. Economically, we have completely flattened. We are going back to closer to the Great Depression time frame. You can look, this is as of yesterday morning from the WHO, World Health Organization dashboard. You can see how we are doing. Some countries are doing better than others, but the point of this is we are still not ready. The governments haven't come to a stage where they could face such an epidemic, or pandemic as they call it now. And it is a big problem all the countries are facing. You can see the number of deaths going up, and some countries have flattened it. Luckily, where I am in Australia, we have come a long way in the last few weeks, or months I should say. We have completely contained it, and it's still there. We are still working from home and whatnot, but it has been contained significantly. But I wanted to set the platform by saying that the speed at which the governments, companies, research institutes, education institutes need to act has become so fast than ever before, and that's what we are facing now. Now, what does it mean from a vaccine perspective, for example? A typical vaccine takes 15 to 20 years before it comes to market. We do not have that much time frame today because this virus is acting so fast, it's being so smart. We need to find a vaccine very quickly than 15 years. We don't have 15 years is the reality. Again, Bloomberg mentioned that this is the world's largest work from home experiment. We can say whatever we want. End of the day, what is reality is we need to act fast in whatever field you are in. Our Prime Minister once said a couple of weeks ago, if you have a job, your job is essential. That is how the market economy is going. And if you have a job, you have some input that you can provide to the current scenario. Hope I'm making sense here. If I'm going too fast, please let me know. Okay. From an evolution of technology perspective, what you see in the left should be very familiar for all of you, being in electronics field. Again, the reason I'm mentioning that is we have come a long way. Don't get me wrong. When I said about speed, it's not in all fields. We have come a long way in certain fields in technology. There's no doubt about it. Now, where we need to go using this technology we are evolving every single day is what we are talking about. So again, a very quick preview of something IBM has done, IBM Research has done. This is to correlate where we were and the pathway we were taking from a transistor perspective, from our electronics or communication in general, to where we are today. What are we doing from a research perspective? What are we doing? Again, I'm not sure how many of you have seen this. I'm going to play this video. Let me give you a context before I do that. This particular film, it's a short film This one Guinness World Record for world's smallest stop motion film. This was done by IBM Research, and this showcases. Let me play it first, and then we'll talk about it. At least I don't want to give you or break the suspense for you. Have a look. It's a 1 minute video. Hope the sound comes through okay as well. Please let me know if it's not. But I'll quickly come back and talk to you about it. Can you hear the sound okay? Can someone confirm? No audio? Okay. Okay, I'm going to play it. Let me talk as it goes. I'll talk to you about it. I'll pause and I'll talk to it. Okay, what you're seeing there are real atoms. So what our research team has done is using carbon monoxide atom, two of them, and they try to move it to one place or other to create this movie. So what you're seeing there is 100 million times zoomed with a microscope, and they created this movie. The context of this movie or concept of the movie is a guy that you're seeing there is playing with an atom. You can imagine that atom as a ball. This guy is playing with an atom, and it takes different forms, and you should put it in the context of 100 million times zoomed in version of a carbon monoxide atom. Let me go to my presentation again. Okay, so what you saw there was, as I said, carbon monoxide atom. They zoomed it to the level of 100 million times, and they moved these atoms, two of these, so they moved these two atoms to form this whole film. So they shot individual frames and made it as a movie. That's what you saw. And this won the Guinness World Record for the smallest stop motion film. Why bother doing it? What was the reason behind this exercise? It's not just someone having fun with atoms. Yes, they did have fun with atoms, but the reasoning, the rationale behind this exercise itself was the amount of data we have today, and we are collating every single day, and it is growing at an exponential range, as you know. And say 16 gig thumb drive is of no use today. We are looking at 128 normal usage, and extrapolate that to a commercial landscape. That is what we are dealing with. So what the researchers found was, as I have written there, the current technology can take about 1 bit takes about 1 million atoms. But if they get this, the movie, what they have done, if they prove it and if they commercialize it, it is going to store 1 bit of information will be stored in just 12 atoms. You can imagine what it will do to the whole landscape around data storage. This is why IBM Research took this initiative, and they have proven that it can be done. They can play with the atoms at that level to prove something. Again, the point I'm illustrating here is, yes, the evolution has happened massively, in a massive range from where we were to where we are today, and what we are playing with. And that is a massive, massive advancement in technology. We cannot miss that fact. Now, when we talk about revolution, when we talk about technological revolution, those numbers on the top are IBM figures. Obviously, we have spent about $45 billion in research and development overall. Just last year, 2019, we have spent about $6 billion. This is specifically around cloud, AI, blockchain, and quantum computing. Again, we will talk more about it as we go, but the point I'm illustrating there is this is what we need today. We need more research coming into how we can make technology better for future. Underlying requirement we think of every day, our research labs think of every day, is tomorrow's technology should be better than today's. What do we do about it is basically the question they ask, and they keep trying different things. In line with that is the number of patents, the US patents we get every year. Last year was 9,262 US patents we got. And I'm very proud that IBM has the patent leadership for the 27 straight years. You can think of IBM as a technology company, but unless we do such research, unless we come up with new patents and new advancements in technology, we won't be here today. And hybrid cloud, again, I wanted to stress that point as well. That is the core of our discussion today. I want to make sure you understand the scale of the market opportunity we have. It's estimated around $1.2 trillion worldwide purely on hybrid cloud. Now, what does it mean? What does this technological revolution mean in simple terms, and how do we relate it to you and me? End of the day, these are the three factors that determine the technological revolution: the phenomena of data, value of cloud, and scaling of the artificial intelligence, AI. Now, when you talk about data, as we discussed just before with the movie, it is growing exponentially. Unless we treat it in the right way, it is going to be a problem we have in two ways. One, structured data. Second one is unstructured data. Structured data, we do have some technology is there today which can handle the structured data to some extent. But unstructured data, it is an evolving field. A lot of companies are taking it on. They are coming up with new technologies and they are trying to address it one way or other. When we say unstructured data, it could be free form, people asking questions and the answer coming out. And that is very much needed in medical field today, because we have, say for example, X-rays and MRIs, classic example. You have that in massive volumes, but once a doctor looks at it, makes a prediction, it goes away. But what we are doing today is digitizing it so that all this knowledge is collected in one place, and next time a similar thing happens, we have the artifact from last time which can be used by the doctors, and that is happening today as we speak. Mayo Clinic is one such organization in the States who are in the tipping edge of all technology related advancements which they try in their institute. Mayo is the spelling, Mayo Clinic. They do a lot of research in the medical field, and they're trying different things, especially with IBM as well. They do a lot of stuff with IBM. Scaling of AI. AI can be in multiple levels. When we talk about scaling is how do we spread it to the mass? How do we apply it in multiple fields? End of the day, it is all about use cases today. Whatever we learn, whatever we try, unless it has a use case that is applicable to the end user, which is you and me, it is not going to be matter. So whatever you do in your field, if you think of a use case, apply to a scenario which gives you a benefit out of that thing you are trying, whatever that could be, you are going to fail. So in other words, we need to find an application oriented use case which you need to apply. A classic example would be Watson. And again, I'm not sure how many of you have seen this. Whatever videos I'm showing, these are all publicly available in YouTube. What IBM did back in 2011 was we created an AI engine called Watson, and this whole setup, what you're seeing there, is from Jeopardy game. It is a game that is very famous in US. It's a quiz game basically, and we put Watson to the test against two of the world number 1 and 2 Jeopardy winners. That's what happened in 2011. We gave Watson all the inputs. So you can imagine structured and unstructured data was fed into Watson, and it was becoming smarter and smarter by the day. And once the question is asked of Watson, it thinks, looks at its database, checks what is available in its database, gives the answer. And Watson won that competition and won $1 million. So this was the first application. If you go back to the three technological revolution factors I was talking about and apply it to Watson, that's exactly what has happened. The data was input. The cloud in that time, 2011, we didn't call it cloud. We called it cluster computing / grid computing. But the concept is the same. A lot of compute power given to the machine to do the compute very fast and answer, come up with the answer, the right answer, very quickly. And artificial intelligence obviously was there to make that judgment call. So I just wanted to stress that point. Data, cloud, and AI, you are going to see that more and more wherever you look, because all these are going to be application or use case oriented, and that is what the world is about today. Now, from application oriented development I was talking about, the use cases I was talking about, just wanted to give a sample because it applies to any industry you think of. It's not just relevant to a particular industry. It's not just medical. I'm giving you just a set of different industries where we play. When I say we, it is quite common across all companies. We are playing in this field. From a banking perspective, roughly 90% of credit card transactions are running on IBM systems today. 83% of telcos, world's largest telcos, are with IBM. It could be in variety of fields, software, hardware, or infrastructure, but they are with us. Healthcare, again, this is a very important point which I am very passionate about. Analysis of patient treatments and clinical trial data. This speeds up any future requirement. That is the reason we are completely on it, and healthcare professionals are interested to work with us on such a use case. I think I gave you an example on that as well. Shopping, this is a very interesting one. Let me give you just follow me on this. I am going into a shopping center, a shopping mall. As soon as I enter the shopping mall, I get a SMS that says, "Welcome to our shopping mall, Krishna. Hope you enjoy the experience of shopping with us." I walk through the shopping mall, just go into a Nike showroom, for example. As soon as I enter the shop, the salesperson comes over to me and he says, "Welcome, Krishna. Nice to see you again. Since you came 6 months ago, we have got a new suit of shoes that you like, and you do have $100 in your credit that you can apply to buy anything today. Would you like to show up your size shoes where they are?" This is the type of customization we are talking about. And this happened. This was not imaginary. About a year ago, there was a shopping center in Australia, in Sydney, who did this trial. They did achieve everything. It did work as they intended. It worked beautifully. The only reason they couldn't put it in practice every day was safety, customer security. Privacy is a big one. We will talk about it later, but privacy is a big one. We have to be very careful as a company, as an end user, as a consumer. I need to be very comfortable in what someone gets my data. Google, for example. Not sure how many of you have noticed. If you have a Google account, Gmail, if you're just typing an email, just try find attached and do not attach anything in your email and try to send it. Straight away it comes back and says, "You have said you're attaching something, but you haven't attached. Do you still want to send?" What it tells you is that it's not just the big brother is watching. So you need to be careful what you put in social media, what is going out there. And that is why some of these technologies we are talking about, even though they can be implemented today, there are other layers that needs to be factored in before we can implement it in real life. But it is possible today. Property management. Now, this is, I'm not sure how much in Australia, at least some of the like energy companies are using it quite heavily. I've given you a scenario there which says smart buildings using IoT for energy control, Internet of Things. Now, what we mean by that, from an energy, one of my customers is an energy company who is a retailer for electricity. The way they are using it is they put the IoT sensors in very remote parts of their electricity poles. What it does to them is, if there is a bushfire, if there is weather conditions that are not suitable for the pole to withstand, It sends information right back, and these guys can go in and fix it before it gets worse. Before IoT was invented or the sensors were implemented to this level, it has to, the whole thing goes down. Customers call them and say, we have a problem here. And it is like, I mean, a lot of issues around electrocution as well. So all those things have been avoided by technology. And it can be, I mean, you can imagine the scale it can go to. It is just a use case I'm telling you about property management, but it can go to any level you want. Investment, it's a no-brainer, because in picking stocks, for example, obviously the smarts around the AI and the data feed is going to help you so much with finding the right stock for you to invest. Just an example. Application testing, same thing. IT security, as I said, today it is not about just controlling something, but before that, proactively, you need to be able to recognize the threat and find a solution for that as well. How do we do that? That is where the smarts of having the data collected, making the machine making decisions, and then actually doing results as well. Meaning, when the machine makes the assessment, makes a decision, it applies to the infrastructure based on quality controls, and then it applies the actual threat stop measures. Last one is the weather. Again, this is an interesting one, because in 2016, IBM bought a company called the Weather Channel. Everyone in the market said, why is IBM going to buy a Weather Channel company? Weather Channel, as the name implies, what they used to do is collect data from different points. They have multiple satellites sitting there, and they feed that information back to customers. So for example, if you pick your phone and you click weather, you get all the weather from all over the place, and this is being fed by one of the satellites we have. The reason we bought that company was twofold. One, obviously, as I said, data, because data is becoming king in everything you do. This Weather Channel is feeding so much information to this platform, which is cloud, and it lets you make decisions as we go. So IBM made a conscious decision of buying that, and it has been fed into our platforms and enabling our customers to make quicker decisions, faster decisions in a timely fashion. Just to give you a scale of what we are facing with Weather Channel or the application is 550,000 API requests per second is what we are facing. You can imagine the grunt this application need to be running on to take on such a load and then to respond to the requests as well. These are just some of the use cases, and you can imagine anything from a car to a phone, anything you think of, there will be an application, and that is what you should be keeping in mind when we go down this path, because it is not about technology for technology's sake. It's about improving, as I said, tomorrow should be better than today. How do we come up with a use case that is applicable to the end user, to my customer, to my country? That is how we need to think, and this is just a set of examples for you to understand the various use cases we have. Now, from a digital transformation perspective, there are 7 key trends I would like to highlight to you. First one, hybrid cloud. I'll come back to that. We will talk about it a little bit more detail in the next few slides. The other 6 are, I want to touch on those just to give you a view of what else is out there, because I do have a wrapping around slide where I want you to keep this in mind, because this is key. The 7 key trends that they are looking at from 2020 onwards are AI, as we discussed before, edge computing, hyperscale data centers, disaster recovery as a service, containers, and hyper-converged infrastructure. I'll quickly touch on each of these. Edge computing. When you talk about anything for that matter, any technology for that matter, compute, data, and user, what we are talking about is how do we bring this closer? Because we need a faster response to any query that matters. If you click the weather icon app in your phone, you need the results straight away. That is what we are talking about. If you are familiar with something called Content Discovery Network, CDN, it used to be very much familiar. I mean, it used to be commonly used in media years ago. Same concept. How can I get data closer to compute and network closer to compute so that it can act together much faster for the end result to come up? That is what we are talking about in edge computing. Bringing all this closer to the compute spot so that the results can be achieved much faster. Hyperscale data centers. Data centers, you can, as you can imagine, a room, a warehouse, distribution center, whatever you want to call it, a rack sitting, having all these servers just stored away with storage, but it cannot scale. That is what we are dealing with today. I have multiple data centers I have dealt with in my career in IBM. What we are dealing with now is the expansion, the scalability that goes horizontally for our end users. The hyperscale data centers provide that capability. Very simple thing to remember from a hyperscale perspective. You can imagine Facebook's data center, for example, or Google's data center, for example. They cannot be having individual data centers that are strictly within the confines of the four walls. These data centers need to talk to each other. They need to expand with the load. That is what we call as hyperscale data centers. Disaster recovery as a service. Now, DIA has been around for yonks years. There is no questions. You can imagine if I have a photo in my laptop, file in my laptop, if I'm putting it in an external hard drive, I'm taking a backup. It is a very simple version of disaster recovery. But we have come a long way from that as well. Instead of having a server set up in my production infrastructure, replicated into my disaster recovery data center, that is the traditional way of doing DR, what we are expecting, or customers are expecting from industry leaders, is how can you make it consumption based? For example, classic example and very simple example is electricity and water. The way electricity and water works is you pay for what you use for. If I use electricity longer in a month, I pay more. If I don't use, I'm going to pay less. That is what basically cloud is about. I want to be able to consume a service based on what I need. It's not about monthly expense, it's about what I need at a particular time or a day in a month. Exactly the same thing with disaster recovery as well. That is the expectation of the customers today. How do you make it consumption based? How do you make it by usage, as I said, and how do you make it more accessible to me as the end user? Containers, again, it's a very interesting concept that has come up in the recent times. More and more cloud comes up. We are talking about containers very much, and that is something that we all need to keep in mind. In simple terms, containers, you can think of them as shipping containers. That's a very simple analogy, and that is how the name came up as well. The shipping container will have a 20-foot container, for example, will have the contents of your house if you're shipping to somewhere, or a company's stuff, and it is ABC company's stuff in one single 20-foot container. So if I pick that 20-foot container, I know it is all ABC stuff. That is exactly what we are talking about in the technology concept as well. What we are saying in containers is I create a container which does one single function. That's it. And it is really good at doing that one single function, nothing else. I have multiple containers like that, each doing its own stuff, and it does really well. So I create multiple containers to do a activity, and I ship these containers to multiple clouds, for example. Why do I need containers? Because in a cloud world, you cannot be building stuff from the ground up like what we used to do in traditional IT space. We need something that takes us faster, which can be deployed once and run multiple times, much faster. That is what containers does for you. So the shipping container concept is the simplest to keep in mind. One container does only one thing, and it does it well. And we have multiple containers which does multiple things. You combine it together to form a particular function. Hyperconverged infrastructure, HCI. Now this is a very new thing. It has come only in the last few years. Now what we're talking about there is making everything virtual. Instead of being physical, you're talking about storage, server, the whole lot. Making it virtual is what hyperconverged infrastructure does, and it brings everything together very closely so that the customer gets the benefit out of this infrastructure much faster. It is an evolving field. HCI is an evolving field, and you need to keep an eye out. Companies are jumping onto the bandwagon to come up with a better solution. There are a few companies like Nutanix who does HCI today. Cisco does it, but more companies are coming into the HCI space. but customers are sort of watching from the sidelines to say, is it something they need at this point or should they wait? So that is again a key trend that we need to keep an eye on. What this has given us is something called, it's a new word they have coined, it's called a new collar jobs. So what it means by that is all these key trends and beyond is creating new set of jobs, and that is what we need our students to be looking at, the new generation to be looking at when they grow. When again, years ago, we used to have Java programming and C++ programming, for example. Now it is much more different than that. The whole world is different. That the students are expected to know certain skills by the time they come out. Application development, for example, for a mobile environment is a default. Is something that everyone is expected to know, which was unheard of years ago. That is what we call as new collar jobs. It is about skills. It's more than education, it's about skills. That again, going back to my original comment about application and use cases that you need to be thinking of. Now, an interesting terminology, as I said, co-opetition is something that has come up in recent times. What do we mean by that? In this current climate, you cannot be a silo, you cannot be working as a silo in your own organization. You need to be working with your counterparts who you might have treated as competition as well. Classic example would be areas where IBM is competing with Oracle, for example, but we cooperate with Oracle in certain other areas. It's just an example. You can think of 100 different things in which fall under co-opetition category. The reason I'm mentioning that is the world we are living in. One of the books that came to my mind when I was thinking of this particular slide is Tom Friedman's The World is Flat. If you haven't read it, you should. He wrote this book years ago, a few years ago now. But at that time, the concept was around, his concept in the book was around the BPO. Call centers going to Philippines, call centers going to Malaysia, India. That was the crux of his book at that time. What he meant was a guy in the States doing his tax or wanting to lodge his tax return is being filed by a guy in India, knowing everything and anything about this particular individual. All his records are in front of this particular person who is sitting in India filing the tax returns for a guy in US. That was very simply put the concept behind the world is flat when Tom Friedman put it. But what we are going through now is the next evolution of what he thought will happen. And every single institute, doesn't matter whichever, you can think of examples yourself, there will be scenarios when we are working together, but at the same time we'll be competing as well. That is the world we are living in. And this is critical for us to understand, because what is happening now is you can't be, as I said, acting in silos, but when you cooperate, you need to think of what the other party can bring to the table, how you can make the use case better for the overall good of the society. And that is how each of the companies are playing today as well. Just want to stress that point because I'm seeing more and more of this happening where I sit, but I'm sure you can relate this to your field as well. I promise you, this is the only slide I have, which will be a little bit more technical. But this, I just wanted to put it in for people who haven't seen the 4 different varieties where we were and where we are today, and what the direction we are going in future. Very quickly, again, if anyone has any questions on this particular slide, please make a note. We will come back to it during Q&A. But I'm going to skim through quite fast. Leftmost on your screen, traditional IT is where we were before. We are not completely out of it yet. 20%, only 20% of the workloads have gone to cloud. 80% still remains on traditional IT. Multitude of reasons are there for that. Customers are thinking that they are not ready. Their applications are not ready because they are so customized that they can't just move it to the cloud. So there are multiple pathways the customer can take. Traditional IT is still there. They have their own data center, they have their own kit, and they are managing it themselves. To all the way to the other side, where very simple example of a SaaS would be, I can give you hundreds of examples. Very simple one is Gmail. I'm making it very, very simple here. Gmail, because they take care of everything. All you are doing is getting a mail service from the provider. You don't care where the data center is sitting or where the server is sitting. All you need is the service to come to you. That is software as a service. Now, you can argue that it is not a software. I'm just giving you an example. Typical software as a service could be Sugar CRM or a Salesforce, for example. That is a typical software as a service, SaaS, and because they give you as a consumable model. So you pay by the month for you to use the service they are providing. So that is the full suite provided by the vendor, and you pay them monthly or daily or whatever that is, and you get the service out of them. That is the other end of the spectrum. In between those two is infrastructure as a service and platform as a service. Now, platform as a service is what we are talking about. From a cloud perspective, we provide, the cloud provider, there are hundreds of them in the market today, including obviously IBM, Amazon, Azure, which is Microsoft. We have Rackspace, we have many more. Alibaba, for example. So we provide, the vendors provide you the dark blue bit on the platform as a service column, and you bring your data and applications on top. That is managed by you, or you provide it to someone to manage it. Now, infrastructure as a service is a little bit different. What we do is very limited. The vendor provides you just the platform, meaning, or in other words, just the hardware, for example. Everything else on top is expected to be managed by you, the end user. That is what infrastructure as a service. The reason I wanted to present this is before going a little bit more detail into the hybrid cloud scenario, just wanted to understand where we were and what are the different options available today for our end users and for you and me for that matter. Now, I have a small exercise for all of us. I'm not going to ask you if you have internet. We all have internet right now. I want you to do this small exercise for me. What do you expect from a cloud infrastructure? Very simple question. If you go into that website, if you can help me go into that website, I have given you the link, and use that code 147901 and help me with 3 of the factors that came to your mind about this question. What do you expect from a cloud infrastructure? I'm going to bring up that page as an, yep, I want to see how many of you are entering. Let me know if you have any issues going to the site itself, but it should be very straightforward. Anyone successful in going in? No one has started putting in yet. Anyone trying or anyone having any issues? If you can let me know, please. Thank you. Hope you can see my screen as well. The browser I have, hope you all can see. What it is going to do is show us a cloud, word cloud, as in when you type the words, it is going to populate the screen for us. I have 4 participants put their thoughts. Thank you. We'll give it another minute before I close it off. Someone has tried typing as well. Thank you. Ready and cheaper, technology advanced, low cost computing, interactive, data mining, good one. Low cost computing is an interesting one. We'll come to that. Booming technology, that's a good one. Storage. Security is a good one. Okay, give me 4 more. 15 people. I'll stop at 15. 3 more. Higher uptime. Nice. Okay, 2 more, or should we stop now? I have 13 so far. Okay, let's stop then. Nice. Okay, thank you for that. Okay, so the main one, the reason security is highlighted is many people have included or input security and storage. That is why it is highlighted in the center. That's perfect. Thank you for this, because it tells me what your thought process is around cloud as a consumer and also someone who is thinking of cloud computing. This is good because few key points there. I'll pick on that before we go back to the slides. Security is quite big because it brings down to what the vendor is providing the end user. How secure is the infrastructure for you to trust in taking a cloud solution? The next one I thought I'll talk to is low cost computing. Now, that is debatable. We have seen customers are thinking that cloud is the cheaper option rather than traditional IT. Moving to cloud gives them a very cheap IT infrastructure. And within 2-3 years, if they don't choose the right application to be put on the cloud, if they don't choose the right vendor for their application, they fail and they come back to traditional IT. We have seen many times because they don't do proper planning, they fail in that exercise and they come back to traditional. So keep that in mind. Low cost computing is not always true with there is a star. Basically, there is a star on that terminology. Low cost computing is not by default given in cloud computing. Now, technology advanced. I'm going to sort of rephrase that in explaining that term. Whoever mentioned that, thank you for that. The way I'm going to explain that is, you don't have to worry about the technology, underlying technology. As an end user, the customer should only consume and without worrying about the platform underneath. That is where the technology, advanced technology, comes into play, because it is not my problem anymore. The vendor has to take care of it. Speedy and good support is a good one as well. Thank you for that. It really helps me understand what your thinking is, and hope I address the main ones you have highlighted. Storage, again, by default, cloud provider is supposed to provide you the best storage possible, faster storage, closer to the data, so that you can compute what you want to. Okay, let me go back to my pack. So we did talk about some of these items you raised. What I'm going to touch here is the type of cloud providers. I did mention there are variety, more than 100 cloud providers in the world. Key about top 10, you will know this. You should suspect the names I mentioned as well. Factors to consider when you're talking about hybrid cloud. Let me start by saying that when we talk about hybrid cloud, there are 3 terms being used: hybrid cloud, multi-cloud, and private cloud. Very quickly, private cloud is what you have in your data center. A hybrid cloud is a combination of private cloud, which is your data center, and a cloud provider like IBM. The third is multi-cloud, is where you have your data center and also you use someone like a Salesforce for achieving a particular function. So that is multi-cloud. In a hybrid cloud world, there are some things you need to be careful, and that's why I said it is not always going to be a low-cost option. The second one in particular, there are 3: lift and shift, refactor, or modernize is about applications. I'm not going to be, I'm not going too much into detail in this one. Very quickly, I can go, I'll try to avoid. But what we are saying there is, from an application standpoint, how do you choose whether the application should be just taken from your traditional IT infrastructure and put on the cloud, or are you going to redo the design so that it suits the cloud infrastructure? Or are you going to come up with a complete brand new application modernized in the cloud to suit the cloud landscape? That is a significant factor in you getting low cost from a cloud platform. If you get this wrong, the customer is not going to get the benefit out of the cloud. And also, in the same vein, when not to use cloud is also something you need to, the customer needs to think of, because if the application they have been using has been there for say 30 years. I have a customer who has one application that they have been using for 30 years straight, and they have been doing multiple customization as they went along. Now there is no way they can take that application as is and put it on the cloud. They need to redo the whole application, and it's too much expense, and they have decided not to touch that application. That is a conscious decision we need to take before moving to the cloud. Technical debt, what I mean by that is, if you start a project and if you are stopping in between and not finishing, that is considered as a technical debt from a corporate perspective. So you need to revisit it at some stage. So that is something you need to consider before the project is started. Now, long-term view with quick wins along the way. That is what cloud is about. It is not a sprint, it is a marathon. The customer needs to take a long-term strategy and then they start they can achieve in 6 months, every 6 month window, what they can achieve and when they can help in that strategy mapping. Security, I think I have spoken enough. It is a key point. Cloud computing did not come up to the level that is today for many years because of security. That has to be addressed. That had to be addressed about 5 years ago, before the cloud computing really went gangbusters. Now, cybersecurity is a related term you will see everywhere, because we are in a well connected internet world, and cyber is becoming a massive problem. So cybersecurity is a key topic that everyone is interested in. If you are studying something to do with security or cybersecurity, you are well needed in the corporate world. Resiliency and disaster recovery, I've touched on that already. I'm not going to do that again, but just to highlight the seriousness of that as well. IBM estimates the average cost of a data breach is close to $3.9 million. Now, data breach is not unheard of in today's climate. Companies who are slack in how they secure, how they do their disaster recovery, are getting breached every single day. Some companies come out, some companies don't even mention that outside because of branding, but it is happening. So it is a serious topic we are considering, we are talking to our customers about, and it's a hot topic we are discussing every day. Just want to highlight Vodafone Idea, who has worked with us recently. As of last week, it was announced. The CTO has publicly announced that thanks to the hybrid cloud solution they have taken, worked with IBM on, they have reduced their capital expenditure, capex, by 80%. This is Vodafone Idea in India who has achieved this recently. These are hot off the press, just released yesterday. Both Bharti Airtel and also Vodafone have worked with us in coming up with the hybrid cloud. It's not to showcase what we have closed or what we have won recently. That's not the objective of this slide. It is about the use case again, what they have done. It is not, hybrid cloud is not just about infrastructure or compute. Here, both these scenarios are focusing on network for these providers, telephone providers, telecom providers, and it is the starting point was, the requirement was around networking, and then it expanded into compute and storage and the whole lot. Just wanted to highlight that, and you will see these two cases in the press as we speak. It just got announced this morning. It was put in the press yesterday, May 11th. One thing I'm almost at the last few slides here. One thing I want to highlight, if you haven't come across this, quantum computing is something IBM and many other players are playing in the market. From an IBM perspective, this is our quantum computer, the chip inside, the setup inside, I should say. Don't ask me too many questions on this. I'm not a master in this, but still I wanted to highlight this because this is going to change how research institutes and new technologies get developed. As it says, this is to solve unsolvable problems in many fields, which has limitation on the classical computing. So classical computing couldn't take care of many of the problems areas we had before. Quantum computing is going to help us with that significantly. Watch the space. If you are interested, do have a look at quantum computing in general or IBM's initiative in quantum computing, because lots happening in that field, and it's a fascinating field to keep an eye on. I can't explain a bit more than that, but tell me if you have any questions. I'll definitely try to answer. Okay, now what does it all mean? It gives you a different perspective, different point of view of how we look at the industry today. The skills of the future is not the same as what we used to have. It is very different, as I said. You need to be thinking about use cases, and the focus needs to be use case oriented. Anything and everything you do has to be use case oriented, application oriented. And again, this point I mentioned earlier as well, always we are looking forward, we should be having a strong hold on the rearview mirror. We need to know where we came from, what we have today to leap forward into the next technological advancement. Changing educational landscape. This corona has created that opportunity for all of us. We are seeing it every single day. Our kids are having work from homeschooling every single day. Who would have thought that continuously for 2 full months we will have a education system happening over the internet? That is what is happening today. It is changing, and what the pressure it puts on education system is you need to be ready for adapting to this change. And how many people are ready are going to be the winners. Classical example is one of the research showed that by 2024, this is an IDC result report. By 2024, companies who are not adapting to artificial intelligence are going to be left behind, and the companies who take it on will be 50% faster in how they respond to the market demands. This is something each one of us need to think about. This has given an opportunity, Corona has given an opportunity for us to think about how we handle such scenarios. No one expected such a thing to happen, and it's still not over. So we are dealing with it, and this gives us an opportunity to think about it. Business, again, working closely with government has been happening all the time, but now it is more than ever. How do we help governments to come up with dealing with these problems? Ford, I heard, and GM, General Motors in UK, converted the whole plant to prepare masks, I think, for the corona situation. So governments are working with business and vice versa, and that is critical. How do we make use of that in the future sense? We need to be thinking about it. Okay, how do you get involved if you're interested? I'm giving you a few links here just for you to browse, and if you're interested to go through. The top one is our research website. It does have a lot of information in across all the fields we were talking about and beyond that. I haven't touched, it is just the tip of the iceberg. So much more is there for you to have a look if you're interested. And the Cloud Academy is a good site as well. It's a great source of information for you to get involved, to see what is happening in the industry, and to develop your own research interests as well. My last slide, I just want to wrap it up by giving few information about where business comes more real with community or society. The top one, PTech, it is in India as well. I checked. They came out, I think in 2017 or 2018. They have introduced in India as well. It is a program that has been available across the globe, 24 countries, 150,000 students have been enrolled. What it does is lower economic families, kids from lower economic families can get involved. They get a free digital education platform. They get into companies like IBM where they do internships, and by the time they come out, they come up with a diploma degree or diploma certificate, which puts them in a comfortable position to go further in their studies or to join companies like IBM as a full-time employee. This is a very successful program that's running all over. And in India, it's AM. That link, this is what I found out, that India is also involved in the PTech program. IBM Corporate Services Co. is a pro bono activity that IBM has been doing for many, many years, where they form a team and send it to a different country. I had the fortune of attending one of those back in 2011. I went to Kenya for 5 weeks to work with the government in solving their problem. So we identify one problem, 11 or 12 people from different countries come together, IBM people come together, we solve the problem for the end user. It could be government, it could be an organization. A lot of teams have come to India as well. This is something where we give back to the society. Same thing with Smarter Cities Challenge as well, where we identify one city, we go in, we solve a problem for them in a shorter period. And these are all sort of charity work we give back to the society. The last one could be of interest to some of your students, is Call for Code Challenge. It happens every year, and last year we had 180,000 developers from 165 countries create more than 5,000 applications. Again, application oriented for a particular problem. Last year the focus was disaster relief. This year, 2020, I think the applications closed just last week. There were two topics. One was Corona, because we wanted a quick a fix to the problem. So we had one as Corona. The other one was, I'm pretty sure it was something to do with natural disaster. So there are two topics this year. Last year it was disaster relief. Do have a look at the site. It is for developers, but again, nowadays the students are so interested in developing stuff. This gives them a platform, and the winning team will get $200,000 as a reward money. That is what I have right on time, I think 1 hour. But I'll stop here. Any questions? Mrs. Chelvi, do we have some time for questions? Any questions for me? Either I have done a real good job or I have done a crappy job. I don't know. I hope it is the first one. Thank you. Thank you. Sorry, can I get your name, please? Uh, Hello, Mr. Dr. Radhakrishnan. I just saw your name as well. In what context would you like me to talk to it? I will be able to give you some information, but I need to come back to you if you need more details. From an IBM perspective, what we are doing is QS. Okay, so the example I quoted from my energy sector perspective, the way we are handling that is we are working with third-party providers from a sensor because these needs to be smaller sensors, and we are wrapping around with IBM security services, and the ELA, the SLAs will be linked to the cloud platform we get the data across to, and that is how we are providing the end-to-end capability for the end user. Does that make sense? I can give you a more detailed answer. If I can take it offline, I'll come back to you. But very quickly, yeah, yeah. Thank you. Any other questions?